Hello again. Going to get through this pretty quickly. We only got 3 pages of notes here. We're really talking about the average value of a function, similar to the total amount of change, which is the previous lesson. But average value of a function is going to be a little bit different. So we start off there. 2 things we've talked about already. How do we find the average velocity? How do we find the average acceleration? The average velocity, just remember that we have to use the position function. So P of A minus P of V. P of B is equal to A minus B. And then you can very easily switch those if you would like. P of B minus P of A, which is over B minus A. The average acceleration, you would have to use your velocity function. So we'd have to use V of A minus V of B over A minus B. I got to let my dog out real quick. Very good. He didn't get the memo that I was filming a lesson. So average acceleration is using velocity, V of A minus V of B over A minus B. If we look there, it says, if I have these 2 functions right here, 1 over B minus A of the integral from A to B of A of t dt, I know that the antiderivative of the acceleration is a velocity. So I'd have V of B minus V of A times 1 over B minus A. That is the exact same thing as the average acceleration. And the same is true here if I look at 1 over B minus A times the integral from A to B of V of t dt. I know that the antiderivative of the velocity is the position. So that would end up actually being exactly the same thing and equivalent to the average velocity. So the average value of a function is going to be defined as 1 over B minus A times the integral from A to B of f of x dx. Then it kind of walks us through 2 examples of how to find the average value of a function. The first one would be a calculator problem because there's no way that we would be able to find the antiderivative of this, x cubed times the square root of sine squared of x. So the average value would be 1 over 3 minus 1, because that's my limits right there, 1 to 3, times the integral from 1 to 3 of our function. So I'd end up with 1/2 times 11.696 is this part right here. And then there is our average value. The second one would be a non-calculator problem, just because we know how to find the antiderivative of 2 minus 4x. Antiderivative of 2 is 2x. Antiderivative of negative 4x would be minus 2x squared. So if I'm going from 2 to 6, we would have 1 over 6 minus 2, and then times the integral from 2 to 6 of the antiderivative of our function, which is given. And then I'm just plugging in 6 minus plugging in 2, getting it all the way down to negative 56, and then multiplying it by 1/4. So our average value of that function is negative 14 from 2 to 6. All right, this next page, great question here. A ski resort uses a snow machine to control the snow level on a ski slope. Over a 24-hour period, the volume of snow being added to the slope per hour is modeled by S of t. The rate at which the snow melts is being modeled by M of t. Both S of t and M of t have units of cubic yards per hour, and t is measured from 0 to 24. At t equals 0, so at the very beginning, the slope holds 50 cubic yards of snow. So A, compute the total volume of snow added to the mountain over the first 6-hour period. So we're looking at the total amount of change being added from 0 to 6. Kind of goes along with our last section of notes. So the integral from 0 to 6 of our function S of t, which is given, calculator equals 142.413. All right, dog's back. See, there he is. There's dog. All right. So, second part, find the value of the integral from 0 to 6 of m of t, and then 1 over 6 times the integral from 0 to 6 of m of t, and then explain what each of those represent. So the integral from 0 to 6 of m of t, just plugging that into the calculator would be 81.823. That represents the total amount of snow that melted from 0 to 6 hours. And then 1 over 6, because 6 minus 0 is just 6. 1 over 6 times the integral from 0 to 6 of m of t would be 13.637. That is the average amount of snow that melts per hour. C is the volume of snow increasing or decreasing at t equals 4. So this is talking about a rate. Is my rate of snow increasing or decreasing at t equals 4? So I'm going to write an equation that represents the total amount of snow on the ski slope at any given point in time from 0 to 24. I know starting off there's 50, and I know that S of t, I'm adding the slope, and minus m of t, snow is melting. So if I find the derivative of this function, it's going to be talking about the derivative of the amount of snow on the ski slope. Derivative represents the rate. So the derivative of a of t would be the rate at which the snow is changing. So if we are talking about at t equals 4, we really want to know at t equals 4, the derivative of 50 is equal to 0. The derivative of this would just be s of t. The derivative of this would be m of t. So I have s of t minus m of t. When I plug in 4, type it in my calculator, we get 11.80. Since that is greater than 0, I know that the total amount of snow is increasing at t equals 4. D, how much snow is on the slope after 5 hours? Now we are going to go back and use this function, the total amount of snow when t is equal to 5. So we're just plugging in 5. We have 50 to begin with, plus the integral from 0 to 5 of s of t. That's going to be the total amount of snow that's added from 0 to 5, minus the integral from 0 to 5 of m of t. That's the total amount of snow that's melted from after 5 hours, and we get 95.335 cubic yards. That's the total amount of snow on our ski slope at 5 hours. And then the last question, there's kind of just a hypothetical. I can't say there will be. There typically is a question on the AP tests. I'm going to be a little bit different this year, but that asks, hey, hypothetically, just write an equation for this problem, and then you don't actually have to solve. So this is talking about, suppose the snow machine is turned off at t equals 10. Write, but do not solve an equation that could be solved to find the time t equals k when the snow would all be melted. So I know that a of 10, that's going to tell me the total amount of snow at t equals 10 that's on my ski slope. And then I would need to subtract from 10 to whenever, that's the k part, that my snow would be melting, that would equal 0. And then that's my hypothetical equation. And we don't actually have to solve. All we were doing is just write an equation. Here, just kind of a free response question. This was from 2003. Question number 6, part B. We have let f be a function defined by that piecewise defined function. And it says find the average value of f of x on the closed interval from 0 to 5. Well, if we are going to, I know that the average value would be, since we're going from 5 to 0, 1 over 5 minus 0, right here, 1 over 5 minus 0, times the integral from 0 to 5 of f of x dx. To be able to do that, since it's a piecewise defined function, it has to be continuous for us to use the fundamental theorem of calculus. So I need to go back, kind of working backwards from that, go through the 3-part definition of continuity, which is right here. Here's number 1. Is it defined at the point that's in question, which would be when it changes from one to the other? Yes, because I know that if I plug in 3 to that piecewise equation, I would get 2. Second part, does the limit exist? So we're looking at two things, the left-sided limit, the right-sided limit. I know that if I plug in 3 to the top, if I plug in 3 to the bottom, we get it to be the same number, which is 2, so I know that the limit exists. The third part, is the function value equal to the limit, which it is. It's all equal to 2 right there. So because of that, it is applicable, and then I can go ahead and find out what my average value is, and there it is. That's it. Done for the day.